Good afternoon, my YouTube viewers. It's Crystal here. I decided that I'm going to do a code review on this video, and the reason why is because the code is going to be just a little bit too complex for me to do a code with me or a study with me. So I had to sit there and do the code, and what I'll do is, rather than do a code with me or a study with me, I'm just going to talk you through the code. I think that's the best way to go about this, as I've decided that I'm going to make some changes in the way that I present my work, and so doing the code with me's and the study with me's and the code reviews is just one of the changes that I'm making to how I present my work. So what we're going to do is we're going to do a code review on this program that I've written on its World Exploratory Data Analysis for COVID-19. So the first thing that we want to do is we want to import our libraries. And then what we want to do is we're going to use the after we've imported our libraries, what we're going to do is we're going to import pandas, numpy, matplotlib, and seaborn for this exercise, for this World Exploratory Data Analysis. Exploratory data analysis. So we're going to import pandas, which is a library for making data frames and managing data, and numpy, which is a library for numeric calculations. Matplotlib is a graphics library, and seaborn is a high-level graphics library, which is a higher level than Matplotlib. So after we have imported our libraries, what we're going to do is we're going to take this data set from our World in Data. So you've got our World in Data website here that you can look at, and we've got the GitHub, so you can get it on GitHub. The good thing about this data set is the fact that it's updated daily. So all you have to do is just run it up and it'll be updated every day. So df equals pd read csv, and then the GitHub URL for the COVID-19 data. So now I've printed off this. It's got 162,607 rows. That's for every country for every day, because all of the data is updated daily. So you can see that. And now when we analyze the file, this is the information. So it tells you all about what's in that data frame. And so you can see that it's got 67 features, or 67 columns. And the reason why is because in Python, the first number is a 0. So if it says 66, that means it's going to be 67 numbers. So now what we're going to do is we're going to do a statistical analysis of the total new cases worldwide. And so you can see right here, I summed up all the new cases, and you can see how many that is. That's a really big number. I don't even know, because I know you've got hundreds, and then you've got thousands, and then you've got millions, and you've got billions. So it's a big number. And then we're going to do total deaths. Total death isn't quite so big, but it's hundreds thousands, and millions. So I think it's going to be hundreds. I think it's going to be 24 million people have died from COVID. And then now what we're going to do is we're going to compare the new cases to the new deaths. And so it's 1.4% of the people who came down with COVID actually died from it. Now what we're going to do is we're going to timestamp it, because this is a time series. So we just timestamp it. So we import date time, date equals df date, and df date equals pd to date time, df date errors equals course, and then df head. So you can see how many you've got. You've got, it's only printing up the first 5 rows, because we can't print up all of the rows, because if we print up all of the rows, it's going to take up all of my computer space. But if you come over here, so it takes the date and it just converts it to a timestamp for you. Next thing we're going to do is we're going to look at the countries, see how many countries are represented in this data frame. And so what I've done is I've used a set in this particular block of code. So country equals df location to list. So you're going to convert the location to a list. Set country equals set, and it's an empty set. For I in country, set country add I. So you're going to you're going to go through the location, and then for every country that's in the location, it's going to be added to the set. And the thing about the set is the set will only show up once. The set will only show up once. So you can have USA 10 times, but it's only going to show up one time. And that's the good thing about a set. So we can see, so you've got a total of 238 countries that are represented. But someplace, like you see here, it says world, okay? So it says world, and it has all of the continents, and it has some more things. So there's actually 13 countries that are not actually countries. So when we get into looking at the countries, those 13 countries that are not actually countries are going to have to be removed to make sure that it's not put in there. So you see here that the length of the set is 238, so that's telling you how many countries are in set. But as I said, 13 of those are not actually countries. Now what I've done is I've just given you another way that you can do it that's a little bit different, but it works the same way, except for the fact that I will say that for loops are quite slow, so if you can find out a way to do something in Python that doesn't involve a for loop, then it's best to do it without a for loop. But I haven't actually gone through to look to see an alternative way to do this. And fortunately, the file is not that big, but if the file was really big, then I would have to find an alternative way to do this, because the file would be so big. But now we've got it again, country equals df location to list. So we're taking country, all of the countries in the location, and then you're converting it to a list. And list underscore country is a blank list, an empty list. For I in country, if I not in list country append I. So if I is not if I is not in the list country, then you're going to append the country to list country. And you can see there that it has, again, 238. So it's including those 15 that are not actually countries. Okay. And then what I want to do here, okay, so it's showing you, it is printing it all out. I was a little bit worried that maybe I was giving you not the right code, but it is printing it out. So now what we're going to do is we're going to create a data frame of the country statistics. And because the only thing we want is we want one row for each country. That's what we want, one row for each country. And so this is the way I just figured out how to do it. Somebody else might decide to do it differently. Country underscore DF is a blank list. Country underscore list is a blank list. For I in range, len DF. If DF location I, not in country list append DF location I. New row equals DF dot ilog I, country underscore DF append new row. Print len country DF. And again, it's giving you 238 because what it's including those 15 countries that are not actually countries. So then the next thing we want to do is we want to take country DF and we want to convert it to a data frame. So country DF equals PD data frame country DF. And now what we're going to do is we're going to drop all of the rows that have not applicable, that are not a number in the continent column. So country DF dot drop in a subset equals continent in place equals true. Print len country DF. So you've got 225. So it's removed those 13 countries that are not really countries. And so now what we're going to do is we're going to do an analysis. You're going to find the 10 most highly populated countries in the world. You've got China is number 1, then India, then the U.S., which I was surprised about that, the U.S., Indonesia, Pakistan, Brazil, Nigeria, Bangladesh, Russia, Mexico. So you can find the most populated countries, and China is the most populated. So let's come over here. It's going to be a little bit difficult to do, but I think it's here this way. Yeah. So 14421 E to the 9th, and then the U.S. is only 3. So China has over 1 billion people. India has over 1 billion people. The U.S. has like maybe 330 million people. So I'm not very good. That unfortunately they didn't put like the real number down. They're like doing it to the value of, which isn't very good. But you can see China is the most populated country, then India, then the United States. And so I was really surprised about that. I was surprised to find out that the United States is the 3rd most populous country. So that's why it's always a good idea to do an analysis. Then you've got Indonesia, Pakistan, Brazil, Nigeria, Bangladesh, Russia, and then Mexico. Now we'll find the 10 least populated countries. So you've got Pitcairn, Vatican, Tokelo, Niue, Falkland Islands, Montserrat, St. Pierre, St. Helena, and Nauru, Wallis, and Futuna, and I can't even pronounce most of these names, but we'll come over here, see if we can find it. I think that might be here. This might be the right one. Population. So the least most populated country is 47, and then it's going to be 812, and it's going to be 1368. So you do have some countries that are very minimally populated. So now what we do is we find the 10 countries with the lowest GDP. Let's see what we've got here. So the 10 countries with the highest GDP. So that's Qatar, Macau, I don't know where Macau is, Luxembourg, Singapore, Brunei, Ireland, UAE, Kuwait, Norway, and Switzerland. So the United States does not even figure in there. So the United States has a reputation as being a really rich nation, but its GDP is not even in the top 10. So the next thing we're going to do is we're going to look for the lowest GDP. So we've got Central African Republic, Burundi, Liberia, Democratic Republic of Congo, Niger, Malawi, Mozambique, Sierra Leone, Comoros, and Madagascar. So these countries have the lowest GDP. Then what we're going to do is we're going to look for the countries with the highest life expectancy. So that's Monaco, San Marino, Hong Kong, Japan, Macau, Cayman Islands, Switzerland, Andorra, Singapore, and Spain. And you see the United States is not in there. And the United States has a reputation for being so rich and the land that fantasies are made, but it's not got the highest GDP. It's not got the highest life expectancy. Now we go to the 10 countries with the lowest life expectancy. Central African Republic. Let's just see. Nigeria. Let's just see if we can find out what their life expectancy is. Let's just see. So the lowest life expectancy is 53.28 and then 54. So those are your lowest life expectancies. So I've already outlived the life expectancy for some of these countries. For Central African Republic. So a lot of these countries that have really low life expectancy are actually in Africa as well. I mean, I don't know where some of these countries are because geography isn't my strong point, but you can always look it up. And I think that most of them are in, oh, it does say continent Africa. It does say. So the lowest life expectancy in these countries is Africa. And the highest life expectancies are Europe and Asia and North America. So now what we're going to do is look for the countries with the highest Human Development Index. And so that's going to be Norway, Ireland, Switzerland, Hong Kong, Iceland, Germany, Sweden, Netherlands, Australia, and Denmark. So your Human Development Index just kind of like tells you, is that a nice place to live? Do they have lots of services and things like that? And you can see that most of the countries with a high Human Development Index are in Europe, but you've got Hong Kong and then you've got Australia that also have a high Human Development Index. But the U.S. isn't in there, so the U.S. has this reputation for being, the land where fantasies are made, but it does not have a high Human Development Index. It's not in the top 10. Now we're going to look in the countries with the lowest Human Development Index, and it's all in Africa: Niger, Central African Republic, Chad, Burundi, South Sudan, Mali, Burkina, Sierra Leone, Mozambique. So again, Africa has a low Human Development Index, has a low life expectancy, has a low gross domestic product. So the thing that I would say about Africa is this continent has a lot of potential for growth. That's the best thing you can say. It's got when you're at the bottom, you can always go up, So now what we're going to do is a graphical representation of our new cases. And we're going to be using Matplotlib and Seaborn for this. And you can see the most new cases were in North America. And part of the reason for that is because North America was doing the most testing. And you have a lot of people in North America because the U.S. is the third most populous country, and then Mexico is a populous country as well. So North America has the most new cases, and let's look at the deaths. Okay, so Asia, North America, and South America, they are pretty much similar about the death. So although you had a lot of new cases in North America, not all of those people who got the COVID died from it. But having said that, I know somebody who I know personally, he was a family member who died from COVID. So although this isn't meant to be a personal video, I just felt, well, I need to bring this up because he died of COVID and this is a video about COVID. So now what we're going to do is we're going to make a heat map. So you can make a heat map. Format equals df.core, fax equals plt subplots, and then it says SNS heat map, core map, vmax equals .8, and square equals true. So there's your heat map. And now what we're going to do is we're going to go through the countries. And I decided that because we're looking at a world view, the only thing we're going to look at is the world. So I called up the world and I just included only the world. So the only thing we're looking at now is the world statistics for 2 years, for a 2-year period. So this is our new cases for a 2-year period, and you notice that they are going down, and people say that we're entering the endemic, we're entering the end of the pandemic. And this is the new deaths, and the new deaths seem to be poignant, but we're looking to end this pandemic. And now we're looking at a ratio to female to male smokers. So you have more male smokers than you do have female smokers. And now what I'm doing is I'm just looking at the world and nothing else. So you can see the world, the new cases of the world in this 2-year period, and you can see that it spiked, but now it's going down again. The same thing with the new deaths. It's very buoyant. We can see the median age of the world is 31 years. the GDP per capita of the world is 15.5 thousand. Extreme poverty of the world is 10. Cardiovascular death rate of the world is 233. Diabetes is 8.5. Female smokers is 6.4.5. Male smokers is 34.5. Hospital beds per thousand is 2.7. Life expectancy of the world is 72.5. Human Development Index is 0.7375 of the world. So this is our analysis of the world with the pandemic in sight. And you can analyze anything you wanted. I just selected a few things to analyze to perform this exploratory data analysis. But you can analyze anything. You can take any of the statistics and you can analyze them as much as you want. But I just picked these out just to show you a few things. And I will say, I did spend a lot of time this morning trying to work out this algorithm right here to create a new data frame. So all of these algorithms are mine, except for the plotting and graphing. I'll probably borrow that from somewhere. But the specific algorithms, like for finding the countries and things like that, they're mine. So that concludes this video. I hope you liked the code review. I hope you got something meaningful out of it. And I look forward to making more code reviews in the future for you.